in doing is to calculate the central tendency and the variance of probability distributions. So before we introduce the probability distribution, first we talk about data. So we have group data and ungrouped data. And now we only talk about the population. And of course, the only difference when we mention population and sample is that for variance, okay, for the population variance, we have 1 over n, right? And for the sample variance, we have 1 over n minus 1. Okay, so that's the only difference. So for ungrouped data, we have 1 over n summation xi, right? And for group data, we have mu x is equal to 1 over n summation xi fi, right? And so that is actually summation xi times rfi. After we mention probability distribution, we talk about the same thing, mu x, but it is now called expectation. So it is expectation x, right? And what is that equal to? That is equal to summation xi times p xi, right? This is for discrete type, okay? This is for discrete type. For the continuous type, it's going to be mu x, expectation x, okay? Integral, okay? Integral xi, fxi, and dx, okay? And then what about variance? For variance, we have sigma x squared, okay? And that is equal to 1 over n summation xi minus mu x squared, right? And then the same thing here, okay? For group data, it is 1 over n summation xi minus mu x squared times fi. This is frequency. And of course, this is going to be this is going to be summation xi minus mu x squared times relative frequency. Okay. And what about here? Okay, the same thing we have. Okay, but because this variance, right? Variance is called Vx. Okay, and that is equal to summation. Okay. Summation xi minus mu x squared times p xi. And what about here? It's going to be Vx squared sigma x squared, Vx sigma x squared, that is xi minus mu x, it should not be xi, it should x, okay, minus times fx and dx. Okay, so basically it is the same thing, okay, basically it is the same thing. But here there is something quite important, okay. So let us try to simplify this part, okay. Let us look at this part and try to further simplify here, okay. So we have Vx is equal to summation xi minus mu x squared times pxi, right? Remember, we have a formula to simplify this. Okay, let us look at this first. So we know it is going to be 1 over n summation xi squared minus mu x squared. So this is one way to simplify it, okay? Remember that? And we have shown twice. Once is for the population variance, the other is for the sample variance. We show how to simplify it, right? And now we want to get to this part, how to simplify it. Okay, so the same thing, first we have to extend it, okay? So summation xi squared minus 2xi mu x plus mu x squared times p xi, okay? Any questions so far? It is very simple, right? A minus b squared is equal to a squared minus 2ab plus b squared, okay? Any questions? Okay, the same thing. Because this is from I is equal to from 1 to n. And this one is xi, so it is affected by this operation. And so you cannot factor this out. So we have to, and also you've got to remember you have a pxi here, right? So it is going to be summation xi squared times pxi, okay? And then minus 2 summation xi mu x pxi, okay? And then plus summation mu x squared pxi, okay? Any questions so far? Any questions so far? Okay. So here, there's no way to simplify it because xi squared and pxi, okay, it is simply here. Okay, so let's put it down. Xi squared times pxi minus. Okay. Can we get this out? Can we get this out here? Is it affected by I? No, right? It is not affected by I. Okay, so we can take this out. So it's going to be 2 mu x summation xi pxi, right? Because this one, it is xi, right? And then the other one, pxi. Both items are affected by this operation, so you cannot take these out, okay? And then here, right, you can take mu x squared out, the same thing, because it's a constant, okay? This is a known number, so you can take it out. Plus mu x squared times summation pxi. Okay, I want to erase this part, okay? Okay, so the same thing, this part going to be xi squared times pxi. Can anyone tell me what is this equal to? The girl in gray coat. So what is this equal to? What is this part equal to? Sorry, I just erased it. If you look at your note, you should be able to find some clues there. What is this part equal to? Mu x, right? This is mu x. So then you have minus 2 mu x squared. Okay? What about this part? What is this part equal to? The girl in red coat. What is this one equal to? What is this one equal to? Okay, the next one. What is this part equal to? This is the property of probability. Okay, the girl in red shirt. What is this equal to? You should be able to find some clues. Mr. Wu, what is this equal to? One, right? Because here it is from I is equal to 1 to n, right? From 1 to n. And here it is xi, so that means the whole sample space. So what's the probability? It is equal to 1. Okay, so then you have plus mu x squared. Okay, and what is this? This is going to be xi summation xi squared pxi minus mu x squared. Okay, this is very important here. So we say expectation of x is equal to summation xi times pxi, right? So if expectation of x is equal to summation of xi times pxi, and what is this? This is summation xi squared times pxi. So what should this be? This should be expectation x squared minus mu x squared. Okay? So because here it is x, so it is x, right? And here it is xi squared, so it should be xi squared. Okay? So this is a simple way, match this one, match this one, right? And this one, match this one. Okay? So in this case, we get a new formula. What's the new formula? So we know here it is Vx, right? Here it is Vx. So this one is equal to Vx. So what does that mean? Expectation x squared is equal to Vx plus mu x squared. So you should keep this in mind, okay? Memorize this. This is a very important formula, okay? So because of this, we know Vx can be, Vx is defined in this way, right? It is defined in this way, and then because of the simplification process, we found out that, okay, actually Vx is equal to expectation x squared minus mu x squared, and that is equal to Vx, right? Because of that, we know expectation of x squared is equal to Vx plus mu x squared. So this is very important. Okay, this is very important here. Questions? Okay, let us get to Chebyshev inequality. So basically, if we know, if we know the probability distribution of a random variable, then we know, what's the probability of certain kind of situation happens. But sometimes we don't know anything about the distribution that we are interested in. So what's going to do? In this case, there is a Chebyshev inequality. It tells us that even though you don't know anything about the probability distribution, still you can find out the probability of the certain events will occur, okay? The probability of certain events, whether it will occur or not. So here, let us simply look at the formula, okay? The formula is down here. So probability of x minus mu x, absolute value, that means the distance, okay? If any point, the distance between the mean is less than or equal to k sigma x, if this is the case, then we know the probability will be at least 1 minus k squared, okay? 1 over k squared. So basically it is like this. Can I erase this here? Okay? Okay, so basically this is the formula, and so even though you don't know, the probability of x, you don't know the distribution of x, but if you can find out the mu x, that is the mean and the variance, still you can find out what's the probability, okay, of certain events you're going to happen. So let us say any point of the data, okay, it is within, okay, k sigma x, okay, within k sigma x of mu x, then you know that, okay, the probability distribution is going to be at least 1 minus 1 over k squared, okay, at least 1 over 1 minus k, 1 minus 1 over k squared. We're going to talk about some of the examples so that you know the properties and why we have this kind of Chebyshev inequality. Okay. And now we get to the functions of random variables. Okay, functions of random variable. So in this case, we say if you cast a coin 2 times and x is the number of heads shows up, and if w is equal to 2x squared minus 2x plus 1, okay, then what is the probability distribution of w? Okay, so here, what we are interested in is okay, x and w, right? We already know x. What is x? X is the number of heads shows up, and x is you cast a coin twice and the number of heads shows up. So we know x has 3 possible values. The first one is 0, the second one is 1, and the third one is equal to 2. So what's the probability that x is equal to 0? It's going to be 1/4, and here is 1/2, and here is 1/4. Okay? So we have done it as time. We can find out what is the expectation of x and also variance of x, right? We have done this before. So if you check your note last week, you should be able to find out the answer. But you know, this is not what we are interested in. We are interested in a new random variable, and this random variable is w. W is equal to 2x squared minus 2x plus 1. Okay? So in this case, there are 2 ways to do it. Okay, the first one, of course, is by the more primitive way. Okay, the primitive way is, of course, we know w is equal to 2x squared minus 2x plus 1. So let us try to find out what is the possible value of w, right? We can find out here. What is the possible value of w? So if x is equal to 0, what is the value of w? It's going to be equal to 1, right? And if x is equal to 1, what is equal to, what's the value of w? It's going to be 1 again, right? Okay, and what about 2? If x is equal to 2, then we know it's going to be 8 minus 4 plus 1. So that's going to be 5, right? Okay, so you know that the probability distribution of x, okay, it has 3 possible values, 0, 1, 2. And the corresponding probability is 1/4, 1/2, and 1/4, right? But what about w? So if you're going to put down this, it's going to be w and pw, right? Okay, w and pw. So there are only 2 possible values. The first one is 1. The second one is 5, right? Okay, so what about the probability of w here? When w is equal to 1, what about the value, okay, the probability of pw? It's going to be 3/4, right? 3/4. 1/4 is equal to 1/4. So this is 3/4. And this is going to be 1/4. Okay? So this is one way to do it. But let us try the other way. Okay, let's try the other way. What's the other way? So of course, the same thing, right? You're going to calculate expectation of w. It's going to be summation wi times pwi, right? And what about variance? It is vw, okay, summation wi minus mu w squared times pwi. Okay? Questions? Any questions? So the same thing, right? Originally we say it is x, and now we say it's w, so you replace it. Okay. But there are some other ways to deal with this issue, okay? Because we already know, you know, supposedly last week we already know about x, right? So there should be some way we can deal with it, okay? So how to deal with it? So because we want to know expectation of w, right? This is what we want to know, right? Expectation of w. And then, so it is going to be expectation, and let us plug all these numbers in, right? Because w is equal to what? 2x squared minus 2x plus 1, okay? So that is going to be 2x squared minus 2x plus 1. Okay? Questions? Any questions? So it is going to be expectation 2x squared minus 2 expectation 2x plus expectation 1. Okay. So this is going to be 2 times expectation squared minus 2 expectation x. What about this one? What is this one equal to? This one is equal to summation, okay? Expectation of 1 is equal to summation 1 times pxi, right? What is this equal to? The girl with pink coat. What is this one equal to? Summation 1 times pxi is equal to 1, right? Good. Okay. So, what does that mean? If you know x, and also you know w is a function of x, okay, suppose you know x, you already know the probability distribution of x, and then you know the relationship between w and x, like this, okay? Then, do you really need to make a table? Okay, so a few minutes ago, we have done this kind of table, right? We have done this kind of table, say, you know, the probability distribution of w is equal to 1, and the probability is 3/4, and phi, the probability 1/4. Okay, do you really need to do this? No, you don't have to do this. Suppose you know x, and also you know the relationship between y and x. If you want to know expectation of w, you can do it like this. So this is the beauty of the, if you know the functions of random variables. And if you know one random variable, you can infer what's going on in terms of the other. Okay, so if you know x, then you should be able to figure out what's going on in terms of w. Okay, any questions? Okay, and later on we're going to try to do the PowerPoint here, but somehow somehow there's something that I would like you to take a little time to think about it rather than simply look at the PowerPoint. So, we have, say, a series of numbers. And then here we want to talk about the mean, okay? And then we talk about the variance. Okay? So let us say, okay, we're going to take 10 here. I'm going to ask you folks questions, and we're going to take 10 like it, okay? So what is the mean here? Suppose you have a series of data, right? And of course we have n, okay, 1, we have n numbers, and it is all A, okay? So then, can anyone tell me what is the mean? So the first one, what is the mean here? What is the mean? It is whole bunch of A, right? So what should be the mean? What should be the mean? If I'm going to show you the PowerPoint, the answer is already there. So you don't have any time to think about it or to learn anything from it. So A. Okay, whenever I ask you this question, you want to refer to the formula, the definition of mean, right? What is the definition of mean? Definition of mean is, okay, let us use mu x, okay, is equal to 1 over n summation xi, right? What is xi? x1. What is x1? It is equal to A, right? So 1 over n. The first one is A. What about the second one? A. How many do you have? NA. So what is the mean? What is the mean here? It is equal to A, right? Okay, what about variance? What is the variance there? What is variance? or right? So what's the variance? 0, right? Because there's no variance at all, right? Everyone is the same. Okay. Then let us get to x1, x2, xn, okay? So suppose we have all these, okay? And then of course this is going to be mu x, okay? Can I erase this? You want to remember all these formula, okay? Memorize it. Okay. So we say for this kind of data, it is from x1, x2 to xn. The mean is mu x, and the variance is sigma x squared. Okay? And now, there's going to be a little bit different here. So it is a plus x1, okay, a plus x2, and then a plus xn. Okay, can anyone tell me what is the mean and what's the variance? Next one. What should be the mean here? So this is this is equal to expectation of x, and this is equal to variance of x, okay? So what about here? Each number, right? Originally it is x1, x2 to xn, and now it is a plus x1, a plus x2, and then a plus xn. So what is the mean? Next one. The gentleman in red t-shirt. What should be that equal to? The same thing, you want to apply the formula, okay? You have to get down to formula and think about it. So originally, the mean is equal to mu x, right? And now for each data, okay, for each number, it is added by a, right? It is added by a. So what should be this one? A plus mu x, exactly. Okay, a plus mu x. Okay? Okay, what about this one? Okay, the gentleman in blue t-shirt again. So what should be here? So here, because you know, for each number, you add a, right? You add a. So the mean is increased by a. What about here? Variance. What should be that equal to? Okay, the gentleman in red t-shirt. What about here? Variance. What should that be? The same thing, right? You don't put yourself, into a big space. You have to get down, okay? Get down to a formula. So Vx is equal to expectation x minus mu x squared, right? So what is this equal to? And this is equal to summation xi minus mu x times p xi, right? Okay, so what should be here? If you add or subtract any number, okay, the same number, if you add or subtract the same number from the original data, what does that mean? The variance will not change, okay? The variance will still be the same, okay? Because originally it is x1, x2, xn, right? And now it is a plus x1, okay, a plus x2, and then a plus xn. But what about here? Originally it's mu x, but now it is a plus mu x. So here for the first number, every number comes with a, right? And for the mu x, everyone also comes with a. So a and a will cancel out, right? So then the variance will be here. Okay, let us look at this. let us look at bx1, okay, bx2, and then bxn. So now this one is different from this one, right? This one you add a number, okay, and the number is the same, okay? And here you time it by b, right? So bx1, bx2, bxn. What about here? What should it be? So the last one. What should be here? Excuse me? Exactly. So b mu x, because you time it by b, right? Okay. Still you. What about here? What about here? Variance. Is that right? Mr. Wu? Is it b times vx? Is that right? B squared, right? It should be b squared, because if you look at the formula here, okay? So now you are not looking at you are not looking at vx, you are looking at bx, right? Okay? So then you have expectation bx minus b mu x squared, okay? And what is this equal to? Summation bxi minus b mu x squared times pxi. Okay, because basically p of bxi is the same thing as pxi, right? So this part, it doesn't change here. But what about here? Okay, when you factor this out, okay, when you factor this out, b have to get a square here, right? So then you have summation b squared times xi minus mu x squared times pxi. So what is that equal to? b squared times summation xi minus mu x squared times pxi, and then this is exactly b squared times vx, right? Because it is here. It is vx. So it is b squared times vx. Okay? So when you multiply a constant, okay, when you multiply a constant, then the mean will be multiplied by that constant. But what about variance? You get square. Okay, for the variance, you get square. Okay, one more. So we have a plus bx1, a plus bx2, and etc. a plus bxn. Okay? For this one, what should be the mean? Okay, the gentleman down there. A plus times mu x, right? Okay? Because you got A. Everyone got A. So then you have A here. And then you have the other part here, right? So that is B times mu x. Okay, still you. Sorry. What about the variance? What about variance? B squared times Vx. Okay? The reason is quite simple, because you add the same number across the data, right? All the numbers got A. So when you are doing this kind of operation, okay, because everyone got A, and here you also got A, so subtract out, right? So cancel out. And then, okay, if you look at B here you have to get square, right? You have to get square here. So when you have a data like this, A plus Bx1, okay, then what you get? You get B squared times Vx, okay? Questions? Let us take a break. We just talked about the functions of random variables. So because of the relationship between random variables, so it can make things easier. As long as we know something about one variable and also the relationship of one variable with the other, then we will be able to get the information from the non-random variable, and we don't have to deal with the probability distribution of the unknown one. Okay, so let us say, the example here, we cast a coin twice. Okay, cast a coin 2 times, and x is the number of heads shows up. And so we know this because we have this example so often, you know the probability distribution of x. And now we want to know w, okay? But we don't know anything about w. The only thing we know is that there is a relationship between w and x. So w is equal to 2x squared minus 2x plus 1. If that is the case, we don't need to know the probability distribution of w, because as long as we know x, okay, and also the relationship between w and x, that is enough, okay? But of course, sometimes, okay, because this is just an example, still we will do it this way, okay? So we know the probability distribution of x, 0, when x is equal to 0, you get probability 1/4, and when x is equal to 1, you get the probability 1/2, and 2, the same thing, 1/2. And because we know w is equal to 2x squared minus 2x plus 1. So you know that when w is equal to 1, pw is going to be 3/4. And when w is equal to 5, the probability is going to be 1/4. And so if you want to get expectation of w, that is just easy. Plug in the number, okay? Plug in the formula. Then you get the expectation of w is equal to 2. And then v of w, that is equal to 31/2. Okay, 31/2. Let us try this again. Because we know expectation of x is equal to 1, right? And we know Vx is equal to 1/2. And so expectation of w, right, should be equal to expectation of 2x squared minus 2x plus 1. Okay? So let us try to see if we can find out the answer, okay? So then it's going to be 2 times expectation x squared minus 2 times expectation of x plus expectation of 1, right? And we know here it is equal to 1, right? What about here? Can anyone tell me what is this equal to? So the gentleman in black t-shirt, what is this equal to? 2 times expectation x squared. And what is expectation x squared? We just mentioned it, right? Remember I say this is a very important formula. What is expectation x squared? It is equal to 1. Can you tell me a formula rather than a number? What is expectation x squared equal to? Okay, the girl in pink coat. What is this equal to? Expectation x squared. What is that equal to? Okay, next. Vx plus mu x squared, right? Okay, so this is equal to 2 Vx plus Vx squared minus 2 mu x, right? So it's going to be 2. This is equal to 1, right? So 2 times 1.5, right? This is 1/2. 2 times 1.5 minus 2 plus 1. So what is that equal to? It is equal to 2, right? Okay. Questions? So it is here. So you can use the formula, right? You can use the formula, get W and PW. So that is the distribution of W. And then you can get the answer. What about here? So you don't have to, right? You don't have to get the probability distribution of W. The same thing, you can get the answer. Okay, questions? Okay. So this is what we just have gone through, right? We have gone through all these. And you see, if you've got a whole bunch of data that is OA, you get expectation, that is the mean. The mean going to be equal to A, the variance equal to 0. And if you get x1, x2, xn, the expectation, mu x, and the variance, sigma x squared. And then you have A plus x1, A plus x2, etc. I got something wrong there. Okay, I have to change this again. So you got the expectation going to be A plus mu x, and the variance, sigma x squared. It doesn't change because, okay, if you add for all the numbers the same number A, what does that mean? You don't add or subtract any variance there. The variance is the same. Okay, and then you have bx1, bx2, and then bxn. So what does that mean? That means for the mean, okay, for the expectation, you get a b times mu x. And what about variance? You get b squared times sigma x squared. And then the same thing again, you get a plus bx1, a plus bx2, and to a plus bxn. So you get a plus b mu x as the expectation. And what about the variance? It's b squared times sigma x squared. Okay, so basically what you get something like this. So if you have x, the mean is mu x, variance sigma x squared, and you have y is equal to a plus bx. So what about expectation of y? Expectation of y will be a plus b times mu x. What about variance of y? b squared bx. Okay? Basically, that's the idea there. What about here? Say you have w equals to ax plus minus by. Okay? Then what about expectation of w? Expectation of w will be a times mu x plus minus b mu y, right? So mu x is for the random variable x. Mu y is for the random variable y. But what about here? VW. This is a little bit more difficult because we haven't gone through covariance yet. Okay, but let us say it is like this. Suppose xy, okay, if xy independent. Okay, so let us say they are independent. If they are independent, then it's going to be a squared times sigma x squared plus b squared, okay, sigma y squared. You may think it is a little bit strange, right? Because you have plus, minus, and plus, minus, right? You have plus, minus, but what about here? It is plus, okay? It is plus. We will show that when we get to covariance, okay? We will show that when we get to covariance. But in any case, here it is a, but when it gets to variance, what is going to be? A squared, right? It is b, for expectation is still b, but for variance, b squared, okay? B squared. Okay, questions? Okay. Now we are going to talk about standardization. Okay, what is standardization? Standardization is to change the mean from mu x to 0 and the variance from sigma x squared to 1. Okay? So this is what we call standardization. standardization. So x, originally it is mu x sigma x squared, right? And when we want to change that into a standardization, that is going to be 0 and 1. And how to change that? So we have z is equal to x minus mu x divided by sigma x. So if the mean of x is equal to mu x and the variance is equal to sigma x squared, and z is equal to x minus mu x over sigma x, then the mean will be equal to 0 and the variance will be equal to 1. And let us show why, okay? So first thing first, we're going to talk about, the first one is expectation of z, right? Okay, you're going to get to expectation of z. And because z is equal to 1 minus mu x over sigma x, so you have expectation x minus mu x divided by sigma x. Okay? Any questions so far? Okay? Okay. Because this is a constant, okay, this is a constant, so we can move this out. Sigma x, okay, 1 over sigma x, expectation x minus mu x. Okay? Any questions to this point? Okay. Then what do we have? 1 over sigma x, and then expectation of x minus expectation of mu x. Can anyone tell me what is this equal to? So the gentleman behind the girl with pink coat, what is this equal to? Excuse me? Summation xi times pxi. And what is this equal to? It is equal to mu x, right? This is equal to mu x. And what about this one? Expectation of mu x is equal to what? So this is also a constant, right? It is also a constant. So expectation of mu x is exactly mu x. So you have 1 over sigma x and then mu x minus mu x. So what is that equal to? That is equal to 0, right? So we say standardization of a random variable is to change the mean from mu x to 0 and variance from sigma x squared to 1. So we already proved this one. Okay? The standardization process has changed mu x into 0. Okay? And now we are going to show the second one. So the variance will be equal to 1. So when we are talking about v of z, right? V of z is equal to v of x minus mu x, sigma x, right? Because z is exactly here, right? Z is exactly here. Okay. And also we know when you get this out, okay, when you want to get this out, let me try this again, okay? So just try a little bit more careful here. So you have v sigma x 1 over sigma x, x minus mu x. Okay? Any questions? I just moved this out, right? But still I keep the operation of variance here. Okay? If I want to get this out, what should that be? 1 over what? So the girl, the next girl. Yeah. So what should this be? 1 over sigma x or 1 over sigma x squared. Because this one is b, right? Here it is b, so we say y equal to a plus bx, right? When you get vy, what do you get? B squared vx, right? Okay, so you have b, and then you should have 1 over x squared, right? 1 over sigma x squared. And here you have vx minus mu x. Okay? So here you have, okay, so here, what can it, we can show it here, right? So what's this equal to? Actually, here, if we're going to say y, okay, so if it is, so that means y is equal to x minus mu x. So that means here it is equal to a, right? And bx is here, right? Okay? So in this case, we are talking about variance, right? We are talking about variance. If you add a number or subtract a number, does it affect variance? It doesn't, right? So what is this equal to? This is going to be equal to 1 over sigma x squared times vx, right? Remember, we just talked about it. A plus bx, right? A plus bx. So when you add a number or subtract a number, because a plus bx here, right? A can be negative, right? Here, a is minus mu x, okay? And then x is here. And we know vx is exactly sigma x squared. So what is that equal to? 1. Okay, so we show that the standardization process here, okay? So if you look at here, the standardization process will change, okay, the mean of x from mu x to 0 and from sigma x squared to 1. Questions? Any questions? Okay. Let us move on. Here we have a different example. Let me see what is this example about. I think we just forget about this example. I'm not sure what this is all about. Okay, now we get to a second question. So if y is equal to x squared plus 1, we are going to find out what is vy and what is expectation of y. Okay, so I see. So this is the question. So x is equal to 0, 1, 2, 3, 4. Okay? X is equal to 1, 2, 3, 4, and then you are required to get the expectation of x and expectation of y. Okay, so now finally I realized this is, actually there are two questions here. The first question is about x, okay? So if you get x and then you are required to get expectation of x and variance of x. So basically for this part, it should be easy. You just plug in the number, okay? So the distribution, when x is equal to 0, it is 1/9. When x equal to 1, 2/9. When x equal to 2, 3/9. And x equal to 3, 2/9 equal to 4, 1/9. So basically for the first part, you are required to get expectation of x. If you want to get expectation of x, it is summation x times px, right? Okay, and if you want to get variance, it is expectation x squared minus mu x squared. So basically, if you just have this formula, you should be able to get it. And the second part, okay, the second part of this question is, okay, we get y is equal to x squared plus 1. Okay, y is equal to x squared plus 1. And you are required to find out what is v of y and expectation of y. So for expectation of y, it is a little bit easier, okay? So because y is equal to x squared plus 1, right? So then you have expectation of y is equal to expectation, so it is here. Expectation of x squared plus 1. And you know that. What is expectation of x squared? What is expectation of x squared? It is v of x plus mu x squared, right? So in the first question, we already done we already found out the expectation of x and also variance of x. So here it should be easy. But for the second part, you are required to get variance of y, right? For variance of y, it is a little bit more difficult. So because we haven't taught any formula about this, okay, there is a formula, but here we don't want to bother with that. So in this case, what you're going to do, you have to get probability distribution of y. So you know that when x is equal to 0, 1, 2, 3, 4, then the probability is 1 nice, 2 nice, 3 nice, 2 nice, and 1 nice. So from there, and you know y is equal to x squared, then you can find out when y is equal to 1, the probability is 1 nice, 2, then it's probability 2 nice, and 5, probability 3 nice, etc. Okay, from there you should be able to get variance of y. Okay, any questions? So basically you just apply the formula, okay? Okay, now we gonna do something else. So again, you're gonna cast a coin twice, and x is the number of heads shows up. And if the second try is head, then y is equal to 2. Otherwise, y is equal to 1. So let's do this together, okay? Okay, so we have cast a coin twice. So you have head, 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 tail, tail, head, and tail, tail. X is the number of heads, right? So this is going to be 2, 1, 1, 0. And y, okay, when the second try is a head, okay, then you're going to get y equal to 2. So what about here? It is equal to, what about here? Y is equal to 2, right? And then 1, 2, 1. Remember, we are going to make a joint probability distribution table, okay? So you have x and y, right? Okay? And here you have 0, 1, 2. But what about y? You have 1 and 2, right? So when you make this kind of table, you got to be very careful. So when x is equal to 0, what is the probability is going to be equal to 1? 0 and 1, right? X 0, y equal to 1. What should be here? 1/4, right? Okay, 1/4. What about here? So the girl in red coat, what should be here? When x is equal to 0 and y is equal to 1, what's the probability here? Excuse me? I beg your pardon? What should be here? 0, because you cannot find anything here, right? 0, 1, 0, 2, nothing. Okay. 1, 1. So again, it's you. What about here? 1, 1. 1/4. 1, 2. X is equal to 1, y equal to 2. 1, 1/4. Okay? Okay, 2, 1. 0, right? 2, 2. 1/4. Okay? So you want to check it. Here it is equal to 1/2. Here also equal to 1/2. And then it is 1/4, 1/2, 1/4. So the same thing, right? We know. So if you remember, we talked about this before. We have summation, Pxi, yj, okay, greater than equal to 0, less than or equal to 1, right? And then summation Pxi, yj, and then we should have what? 2 summation, right? That should be equal to 1, okay? So the same thing here. And if you just want to remind you, so then you have summation I p xi, right? And summation j p yj equal to 1. We say you can have summation from the y side first, right? You can have summation from the y side first. Or you can have summation from the I side first. Okay? A little bit complicated, but you want to pay attention to it. Okay. So, what's the question? We haven't got to the question yet. Okay. What's the question? The question, okay, we make a table, right? Oh, boy. Okay, so anyway, let us try to find out something we are really interested in, okay? Let us find out something we are really interested in. And I want to see if anyone can tell me the answer. Okay, so here, I want to know. Are xy independent? Okay, are xy independent? So it's your turn. Or maybe that lady. So the lady in yellow coat. So what's the, are xy independent? What's the way? Okay, first answer this question. How can we know these two variables are independent or not? How to verify they are independent or not? So if x and y are independent, then what should be true? Then px times py must be equal to px and y, okay? But here you have to be careful because you have three numbers, right? You have three numbers, you have two numbers for y, three numbers for x. So then you got to have this p, okay, x equal to 0 times p y equal to 2 should be equal to p x equals 0 and y equals to 2. Can you tell me whether this equation holds or not? Is this one equal to this one? Yes or no? Why? What is this equal to? Px, excuse me? 1. So that's equal to 1/4. Okay, 1/4. What about here? 1/2, right? And what about here? 0, right? Exactly. Because if you are looking at x equal to 0 and y is equal to 2, what does that mean? It is 0. So it is not equal to, right? So are they independent? No. And you know, it is kind of simple. Why? Because what is x? X is the number of heads shows up. So if, including the first head and the second head, right? And what about y? Y, when y is equal to 2, okay, the second one is a head. And when y is equal to 1, the second one is a tail, right? So that means x and y must be related. And also, if you remember, we say when x and y are mutually exclusive, what does that mean? If x and y are mutually exclusive, then they will not be independent, right? Remember that? Okay? So basically, there are several ways to do that. Okay? Questions? And here we have a whole bunch of information here actually that is about conditional probability, okay? Conditional mean and conditional variance. Okay, later we're going to get to that, okay? Okay, it is here. Again, you know, it's a whole bunch of mess. So let us look at the blackboard, okay? Okay, so we want to get expectation of x, right? That is equal to summation P xi pxi, okay? And if we want to get variance of x is equal to summation. So can I erase this? Summation xi minus mu x squared times pxi. Okay, so this is mean and variance without any conditions. And now we are talking about conditional mean and conditional variance. Okay, so then we are going to talk about expectation of x given y happen, right? Expectation of x given y happens. Okay, so what does that mean? That is equal to xi times pxy. Okay, and what about variance? X given y happen, right? So that would be summation of xi mu minus mu x squared times pxy. Okay? For the case we just mentioned, we have two cases, right? The first one is y equals 1 and then y equals 2. Okay? So then in this case, we can have two different kinds of conditional variance, conditional mean and conditional variance. So the first one is expectation of x given y equals 1. Okay, and then expectation of x given y equals 2. Okay, I'm sorry, I erased the table. I have to show you the table again. So let us try here. X and y, right? So 0, 1, 2. 1, 2. Here is 1/4. 0, 1/4, 1/4. And here is 0 and 1/4. So here it is 1/2, 1/2. And here is going to be 1/4, 1/2, 1/4. Okay, any questions about this table? Okay, now we are going to talk about the difference here. So you have the first one, okay, and then v of x, y equals 1, v of x, y equals 2, okay? Any questions so far? Okay, let me show you the first formula and the second formula, okay? Here we want to get expectation of x, right? Okay, we want to get expectation of x, so probability of x is here. So here you get probability of x equals 0, 1/4, probability x equal to 1, 1/2, probability x equal to 2, 1/4, okay? Any questions to this point? Okay, so suppose you want to calculate expectation of x, okay? Suppose you want to calculate expectation of x. So you have to have 0 times 1/4, right? 0 times 1/4. And then 1 times 1/2. And then 2 times 1/4. Okay? What about here? When you want to do this, when you want to calculate expectation of x given y is equal to 1, okay, then what you need to do, summation xi px y equals 1, okay? So in this case, you use px, right? You use px. Here you have to use px given y equal to 1, okay? So can anyone tell me, the first one, okay, still I'm going to use 0, right? For the first one, still I'm going to use 0 because x1 is here, x2, x3, right? What is the probability? What should be the probability I'm going to use? The girl with the black and white strip. What should be the probability I'm going to use? Here you have to use conditional probability, right? So given y is equal to 1 and what is equal to px, okay? So let me erase this part first, okay? So then summation xi times py equals 1, right? And then px is equal to x, okay? And then y equals 1. I mean, here, perhaps I'll better use xi, okay? Because there are three possibilities here, right? Okay, so can anyone tell, the lady there, please tell me what should be here? Excuse me? 1/2, right? Because up here, this one is equal to 1/4, right? And down here it is equal to 1/2. So what is that equal to? 1/2, okay? Okay, the next gentleman. What should be this one? When x, the first one is x equal to 0, right? The second one is x equal to 1. Okay, what should be the whole thing? What should be the probability here? 1/2, right? What about the third one? When x equal to 2 and y equal to 1, what should be this thing do? 0, right? Okay, so here, now you know, when you apply a mean, okay, if you want to calculate a mean, then xi times pxi. What about conditional mean? Conditional probability, okay? The same thing here. The only difference with the mean and conditional mean is the probability here. Here you use probability. Here you use conditional probability. Okay? Questions? Any questions so far? Okay, the only difference between expectation and conditional expectation, okay, variance, conditional variance is the probability. For the first part, okay, you use probability. For the second part, you use conditional probability. Okay. And also, I think you're going to remember this, right? So, when PA given B is equal to PA, can anyone tell me what's the relationship between A and B? So the girl in purple suit, what should this be? What's the relationship between A and B? If we have PA given B is equal to PA, what does that mean? What's the relationship between A and B? Okay, you want to get down to formula, right? What's the formula? PB and then P, A and B. So conditional probability is equal to this, right? Okay, PA given B is equal to PA and B over PB, right? And then is equal to PA, right? So what does this mean? What's the relationship between A and B? What's the relationship between A and B? 任秋贤. What's the relationship between A and B? Your turn. So what is the relationship between A and B? Excuse me? Independent, exactly. Okay? So, when X and Y independent, when X and Y are independent, then you know expectation of X will be equal to expectation of X given Y. And it's V of Y, V of X, sorry, is equal to V of X given Y. Okay? It is very important here. So if you know X and Y are independent, then the mean is equal to the conditional mean. And the variance is equal to the conditional variance. Okay? Okay, questions? Let us take a break.